closer look at case 1 and try and understand why it actually works. If you understand why it works, it's going to be easier to remember. So, in case 1, we have a quadratic in standard form where the leading coefficient on the x squared term is 1, and it is factorable. So, our goal here is to try and factor this quadratic into 2 binomials. And if you remember from the other video, we're going to try and think of 2 numbers that multiply to c and add up to b. But before we do that, let's try and figure out why that actually works. So over here, I have 2 binomials, x plus d and x plus e. So we're going to multiply these out and see what pattern we get. So I'm going to start by multiplying x times x, which gives me x squared, x times e, which gives me ex, d times x, which gives me dx, and d times e, which gives me de. And then I'm going to do a little bit of factoring. So if you look at the 2 terms here, they both have an x in common. So I can factor that x out. So I'm going to get x squared plus x times e plus d plus de. And then I'm going to do one more thing. I'm just going to change the order of these 2 and swap the position of those 2. So I'm going to write this as x squared plus d plus e times x plus de. Now, look, the last term here is the product of these 2. So de is the product of d times e. And then this term right here is the sum of d and e. So if we compare it to standard term, we get that b is the sum of whatever these 2 constants are, and c is the product of whatever those 2 constants are. So that means, in this example here, the 2 numbers that we think of have to add up to this b term of 11, and they have to multiply to c. So if you go through your factors, you're going to figure out that 9 times 2 is 18, and that adds up to 11, and that multiplies to 18. So we get x plus 9, x plus 2 equals 0, and then we're going to set both of these equal to 0. So from this one, we get that x equals negative 9, and from this one, we get that x equals negative 2.